Hello there. So I know this as you're kind of starting this video, seeing this equation is super intimidating, and that's kind of my goal because I'm trying to show you in this video that the long division you see in this question is actually exactly the same as the long division you probably learned in grade 4, grade 5, grade 6, right? All that's different is that we have these x's in there, and we're doing the exact same thing. We're taking this function, okay, so whatever is kind of inside the dividing line here is called the dividend. Okay, we're taking this function, the dividend, and we're dividing it by our divisor, which is 2x minus 3. In pre-calculus 12 or some other courses, they might call it the factor of the function. Okay, and whatever's up here, right, we're going to figure that out, is called our quotient. So the quotient is whatever's left after we divide a number by a factor, or the dividend. Okay, so the first thing we always do is we look at the first number, okay, 2x to the fourth, and we say, okay, how many times does the divisor, right, or the factor 2x minus 3 fit into 2x to the fourth? So it might sound kind of weird. You'd be like, well, I have no idea how many times it fits in it, but all you need to think about is um, the x's in terms of their exponents. So we can fit 2x minus 3 into 2x minus 4 x cubed times, right? Because if we multiplied 2x by x cubed, then the exponent on the x would become x to the fourth, right? So if we take 2x minus 3 and we multiply it by whatever we put up in the quotient, right, we're going to get x cubed times 2x minus 3, so that's going to be 2x to the fourth minus 3x cubed. Okay, so that's kind of the first step, is you say, how many, like what exponent, what degree of x, or whatever the variable is, can we multiply the dividend by to give us the same exponent as what's inside, or sorry, not the dividend, the divisor, to give us what's inside the dividend, the degree of the variable there. Okay, so we have x cubed up top. All right, so we have 2x to the fourth, and we're subtracting kind of both these terms here. So 2x to the fourth minus 2x to the fourth, what's that? That's going to be, well, that's 0x to the fourth, so that's nice. Kind of disappears, right? And we have negative 9 x to the 3 minus negative 3x cubed, right? So that's like negative 9x cubed plus 3x cubed. I'm actually just going to get rid of this 0 here because we know it's not even there. And we get negative 6x cubed. Okay? And then we kind of tag all these numbers down here. We kind of bring them for the ride. Minus 26x plus 12. Okay, that's the first step. So we know for sure x cubed can fit in there. All right, and now our next step is we say how many times can 2x minus 3 go into negative 6x to the 3? Well, if we multiplied it by negative 3x squared, right? So if we multiplied it by negative 3x squared, I'll write it down here. 2x minus 3 times negative 3x squared. That would give us, if we distribute this negative 3x squared, negative 6x cubed, right? And then plus 9x squared. So whatever this is, when you multiply the number you put in the quotient and the divisor, it should give you the same first term as what's already inside the dividend. Okay, so keep that in mind here. So the number we put up top is negative 3x squared, and we're just kind of going to put, right, that subtraction sign, and we should always get the same number in here. So just to really drive this home, these two numbers should always be the same. So you're thinking, what can I multiply this by to give me the same first term as what's inside the dividend? Okay, and whatever that number is, you should put it up top here. It's going to be part of the quotient, right? So negative 3x squared times negative 3, that's going to be positive 9x squared, right? And like we did in the last step, we're just subtracting all this. So we get negative 6x cubed minus negative 6x cubed. So remember, if this is the same number as what's right above it, it'll just cancel, so we get 0. And we get 21x squared minus positive 9x squared. So that's going to give us 12x squared. And remember, these numbers kind of come down for the ride. And you just repeat this process. Okay, you say, you say, how many times does 2x minus 3 fit into our next number, our next first term, 12x squared? Okay, so 2x minus 3, if we want to get to 12x squared, we have to multiply it by 6x, right? So we're going to have a positive 6x up here. If we take this 2x minus 3, multiply it by the number we have here, 6x, we will in fact get 12x squared, right? And 6x times negative 3 is negative 18x, right? And remember, we're subtracting all this. Okay, so 12x squared minus 12x squared, that's 0. Negative 26x minus negative 18x, that's going to give us negative 8x, right? Because it really means like we're adding a positive if we subtract two negatives. Okay, and remember this 12 comes for the ride. Okay, we have one last step here. Same exact thing, 2x minus 3, how many times does that go into negative 8x? Right? 2x minus 3 goes into negative 8x, negative 4 times. Okay, so if we multiplied it by negative 4, we would get negative 8x plus 12. Okay, so if we subtract this, right, what we'll be left with is 0. So anytime you get a remainder of 0, this last number here is called your remainder. If it's ever a 0, that means that this number here, the divisor, is a factor of the function. So that means you can take this function and you can divide it by this number here, the divisor, and you will get exactly 0. So that's cool. If we take this function divided by 2x minus 3, we get 0. 2x minus 3 is in fact a factor of the function. And this is the quotient. This is the quotient. So that's what you're left with. And what this means is we have 2x minus 3, right? And if we multiply it by whatever the quotient is, x cubed minus 3x squared plus 6x minus 4, right? This is the divisor and this is the quotient. If we multiply the two together, we will get the original function. And that should make kind of some sense because we're taking the function, we're dividing it by 2x minus 3, and we get this quotient. If we take this quotient and multiply it by what we originally divided by, we just get what we originally had. So it's a bunch of, it's a lot of numbers, I gotta say, but if you can kind of follow along, it's not really much different than the long division you learned before. All that is different is that we have x's in there now. And we kind of have to think of, what we need to multiply the divisor by to get the first term in the dividend. So I'm going to kind of come up with another example here. Let's say we take x cubed minus 2x plus, or sorry, 2x squared plus 4x, and then I'll go plus 2. Okay, and let's say we're taking this function and we're dividing it all by 2x. Okay, so we have to say, well, how many times does 2x go into x cubed? And we have to multiply 2x by 1/2 x squared. right? Because 2x times 1/2 x squared, the 2 and the 1/2 will go away, so we just get x cubed. So that is the first number of our quotient. Okay, so 1/2 x squared is going to go up here, and that means that we're going to be subtracting x cubed, which is exactly what we want because that's just 0, and then we kind of tag all these numbers down. So now we have negative 2x squared plus 4x plus 2. Okay? Now how many times does 2x go into negative 2x squared? And it goes in negative 1x times, right? Because negative x times 2x is negative 2x squared, so we got minus x here. Right? And remember, we're subtracting negative 2x squared, right? And then this is really like adding a positive, so this just cancels, and then we tag these next two numbers down to the bottom, 4x plus 2. Okay, and we say, well, how many times does 2x go into 4x plus 2? It goes in 2 times. So we say plus 2 in the quotient, and we subtract 4x, right? We have this plus 2 here that we're kind of, I don't even need to write that. We're subtracting this, and then we're left with 2, and this is the remainder. So see how this isn't 0 in this example? This is called the remainder, and that means that if we take this original function and divide it by 2x, 2x is not a factor. We're going to be left with a value of 2 if we take this whole thing and divide it by this divisor here, 2x. Okay, so how you would write this is, you could write f of x, right, our function, divided by 2x is equal to a half x squared minus x plus 2, right, plus our remainder 2 over 2x. Okay, and the 2's could cancel here, and you could write it like 1 over x, but you kind of get the idea. Whenever you have, like the notation they seem to use is f of x, right, the function, divided by the divisor. So they might use a d here or some other notation equals quotient. So they usually write a q. They might write q of x. It depends, plus the remainder over the divisor. So basically all this is saying is you take your function, right? You divide it by some relation, some set of terms. It's going to equal the quotient plus your remainder divided by whatever you divided the whole thing by. So notice if your remainder is 0, it's going to be 0 over whatever you divided by. So you're just going to be left with q of x, the quotient. So that is kind of how you work with long division and higher degree polynomials. It's not the easiest thing, but it's not significantly different from your elementary and middle school long division. So that's kind of cool. And in the next video, I'll show you how to divide higher degree polynomials using synthetic division. So long division kind of shows you exactly what's going on. Synthetic division, there's not as many numbers to write down. You'll see that you just use like the coefficients, the numbers in front. There's not really many x's or anything. It's a bit quicker, a bit easier, but long division teachers seem to like to start with first, and I kind of like to go along with what the teachers are doing to make sure you guys are following along. So hopefully this helped, and I'll see you in my next video.